English tutorials. I'm going to be doing linear functions or straight line graphs for grade 10s in this lesson. So let's go. Linear function or straight line function. We would normally say straight line graph. Now the general equation for a linear function or straight line graph, it's y equals to mx plus c. The general equation, how to recognize the equation for the straight line graph. You must always see y equals to mx plus c. Normally m and c is substituted with numbers. Could be c could be a 0, and that m also could be a 0. If m is a 0, it makes the whole term to be a 0. Then you'll be having y equals to c. What is m in our equation? M is the gradient of the graph. The gradient of the graph. And remember, the gradient, we define it as y2 minus y1 over x2 minus x1, or change in y over change in x. Right? If you like, the gradient, you could also call it the slope of the graph. The slope of the graph, or the steepness. It describes the steepness of the graph. How steep is your line? The line could be this steep, or that steep, or that steep. That's more steep. Or you could say, if you like, inclination, but we don't normally say it's inclination, because inclination is defined in terms of the angle, which is going to be m is equals to tan theta, right? And then c here, it stands for the y-intercept. C is the constant that stands for the y-intercept, and the y-intercept, we could write it as a point S0 and C, as the point S0 and C. And when we write our point, we start with x and then y all the time. It's x and then y, all right? And we call this again as coordinates. It's either you call it a point or coordinates, all right? And then you write your x and y coordinate system, or your Cartesian plane. Your x and y coordinate system or Cartesian plane. If your line cuts through the x-axis and the y-axis, you're definitely going to be having your line defined by y equals to mx plus c. And your m, because it's going up from left to right, your m is positive, or you can write it as m is greater than 0. M is greater than 0. Or when your line is going down, if your line is going down, then your gradient is going to be a negative, all right? We prefer always to write it in this form. M is less than 0. We prefer to write it as m is less than 0. That is a notation that is used mostly. Okay, this is still the form of the equation mx plus c, because it's cutting the y-axis and is also cutting the x-axis. Okay, so you do have the y-intercept and you do have the x-intercept. Same here, you do have the y-intercept and you do have the x-intercept, right? And then when your line is going through the origin, when your line is going through the origin, then it's going to be defined by y equals to mx, because c is 0. When c is 0, your line is passing through the origin. And the gradient of this, because it's going up, is also m is greater than a0. Okay, if it's going down, passing through the origin, then you are having still y equals to mx, but your m this time is less than 0 and your c is equals to 0. Now this information is very important. You need to keep it in your mind so that whenever you are asked to draw the graph or to interpret the graph, you know that if it's going down, then your gradient is a negative. If it's going up, your gradient is a positive. That is the knowledge that you must take with when you are drawing graphs or applying the straight line graphs. Okay? Doing another type, when your graph, your line is a horizontal line. When your line is a horizontal line, then it's passing through C. Let's say that C is equals to 2, right? Therefore, you are going to be having y equals to C, and your C in this case is equals to 2. Now that is the general form. This will always occur because m is equals to 0. And remember, when m is equals to 0, this term disappears. So you are having y equals to c. Y equals to c, and it will be y equals to a number. Y equals to a number, all right? Because a number, mathematically, we call it a constant, a number without a variable. Okay, now if you are having a vertical line, right? If your line is a vertical line, now in this case, your graph is defined by x equals to a. Let's say that is a, and a is equals to 2, all right? So x is going to be equals to 2. X is equals to 2, and the gradient in this case is undefined. Undefined. Remember, the gradient describes the steepness of the graph. So a line that is vertical, the steepness is not 0, but is undefined. But if it's horizontal, then the steepness is 0. The gradient is 0. All right. Okay. Need some space there. Okay. Now, giving you an example, when we do the dual intercept method. Now already when I talk about dual, you can already imagine in your head that we are talking about two things. And the two things here are the intercept. For you to draw a straight line graph, you always need 2 points or 2 coordinates. Alright, so we are going to do the y-intercept, number one, because it's the easiest. The y-intercept, you let x to be 0, right? So let's give ourselves an example. Y equals to 2x minus 4, right? So we already know that our y-intercept is just a c. So our y-intercept is going to be a 0 and a negative 4. Remember we said for the y-intercept we let x to be 0. So if you put 0 there, that term disappears and then you are left with a c. Hence we say our y-intercept is 0 and c. In this case it's 0 and negative 4. And then we do the x-intercept when letting y to be 0. Therefore we put, this is the one that requires a little bit of algebra to manipulate the equation. So you bring the negative 4 this side, and you have 2x, you divide by 2, both sides. What you do on the left, you do on the right. That's the laws of equations, and therefore 4 over 2 is equals to 2. Always write your points in a coordinate form, all right? Which is going to be 2 and 0 for the y-intercept. Because as said, we always start with x and then we write y. Now, once you have those 2 points, you are ready to draw your graph. You are ready to draw your graph. Okay? We are having 2 here. We are having 2, a 1, and a 0 there in the point of intersection. And then for y, we are having a negative 4, a negative 4 there. And then to write our y-intercept, that's our y-intercept, which is 0 and negative 4. And then our x-intercept is 2 and 0. Every time your y is 0, it will cut the x-axis. And every time your x is 0, it will cut the y-axis, exactly on the y-axis. Your point will be exactly on the y-axis. And your point here is exactly on the x-axis if your y is 0. That's important. And then you can connect your line. You join your 2 points with a ruler, right? And then you have your straight line. Put your arrows there to show that it is going to positive infinity and this side is going to a negative infinity, all right? And your graph, as you can see, it's increasing all the way. It's increasing from negative infinity to positive infinity, all right? You can also do the table method. You can also do the table method, right? Some are comfortable with table method, but I prefer dual intercept method because it gives you exactly the x and y intercept. But here, you may not really get the x and y intercept, depending on what points or how many points are you giving yourself for x. And preferably, you don't have to give yourself many points, okay? So give yourself -1, at least a point before 0, a 0, and a point after 0, all right? And then you can substitute in your equation, and your equation is 2x, in this case is a -1 and -4. Then you are having 2 times -1, it's a -2, and -4, it's a -6. It's a -6. And then the next one is y equals to 2 times 0 and negative 4, that is a negative 4. And then y, 2 times 1, it's a 2, and a minus 4, it's a minus 2. Write this in a coordinate form because you're getting ready to plot this on a Cartesian plane. So for x, we're having negative 1, and for y, we are having negative 6. And here for x, it's 0, and y, it's a negative 4. Upper, you're having 1 and a negative 2. So you're ready to do your points. We can see that the middle point is that one, the x, the y-intercept. Let's draw a new Cartesian plane. A new Cartesian plane, right? It's not a nice one. Let's do a nice one. A new Cartesian plane. A new Cartesian plane. So we're having a negative 4 there and a 0. We're having a negative 1 and a negative 6. Okay, let's put a negative 6 there. Negative 6. We're having a 1 and a negative 2. A negative 2. So that is going to be our 1. Okay, let me change my points. Let's write a negative 3 there, a negative 4 there, a negative 5 there, and a negative 6 there. Right here you could have your 1 and 2, this side negative 1. On your left you're having negatives, below you're having negatives, and above you're having positive y's. On your right you're having positive x values. Alright, and then that's a negative 2. But my points I have negative 1 and negative 6. So you'll be using a ruler, so you should get a fairly straight line. Fairly straight line. Alright, and 0 and negative 4, it's exactly on the y-axis. And then 1 and negative 2, 1 and negative 2, it's exactly there. Right? Well, my points are not giving me a straight line. And let me just put my 1 there and put my 2 there, so that I get a straight line. Okay, for you to get a straight line, make sure your points are equidistant to each other. Okay, then I'm going to have a line there. It's supposed to be a straight line. Supposed to be a straight line. Supposed to be a straight line. Okay. Yeah, so that's your straight line. Okay, if you were to take this line further up, so your 2 is somewhere there. Okay. Now, note something. We've given ourselves negative 1, 0, and a 1. We've given ourselves negative 1, 0, and a positive 1. We did not give ourselves that point that gives us the x-intercept. Alright, so this is the disadvantage of a table method. Alright, it may not give you both the x and y intercept. Alright, the y-intercept and the x-intercept. But here, the dual-intercept method, it gives you exactly what you want. Alright, without giving you the points in between and the point beyond and below the y and the x intercept. So that is very important. All right. Thank you so much. We're gonna go to our part 2, where we are going to draw. I'm going to teach you how to draw the graphs for y equals to mx. Y equals to mx. Thank you very much. Thank you.